Hi, my name is Luis Valladares. I'm going to start presenting our water distribution system for our project. My group is conformed by Shirley Sibar, me, Luis Valladares, Jorge Cires, Carlos Sarmiento, and Christopher Rodriguez. First, I'm going to start talking about the criteria design. Well, for our criteria design, we consider the next aspects as pressure, static pressure, friction, and loss of charge due to friction. As we know, friction and also loss of charge due to friction, we put a lot of attention of all the devices that were conform our system. Also, we gonna use a table, a chart to determine all these losses of friction up, caused by the devices. Also, to determine the pipe diameter, we use the maximum probable flow and also the maximum possible flow. These flows are when all the pipes are open and are in use. For example, we calculate the flow for each section for the critical device to node 1, from node 1 to node 2, from node 2 to node 3, to node 3 to node 2 apostrophe, and to node 2 apostrophe to pump. Next, for the design, we use these norms from the Ecuadorian construction norms for take the flow and the pressures to use. For calculate the loss of friction, we use of the tables of Flamen. As we can see here, this is the table 3.2 that is for the diameter that we calculate. And also, finally, the key QAs that we use this formula to take that result. Thank you.
Hi, my name is Shirley Alcivar, and I'm going to explain about the nodes in our project. Well, this table presents the node analysis for the domestic water supply system of the residence. Each node represents a connection point where different plumbing fixtures are concentrated, such as showers, toilets, lavatories, and kitchen sinks. In the first column, we list each area and devices, indicating the quantity and the unit flow rate, the QI, in liters per second. The product give us the total design for the total design flow for each node. And the building type factor, the F, is and the simultaneity coefficient are then applied to account for the fact that not all fixtures are operating simultaneously. These factors allow us to obtain the probable maximum flow rate and the design flow too for each second of the system. The select pipe diameters, mostly 3/4 inches and 1 inches for the main line, are based on these calculated flows, ensuring that velocities and head losses remain within acceptable limits. We have the minimum velocity that is 0.6 and the maximum 2.5. Well, the material used is PVC with this roughness coefficient corresponding to typical standards. And the final columns show the velocity and the head losses for each pipe segment, which verifies the system hydraulics performance. And we have the tank design too. This table shows the storage tank sizing for the water supply system. The demand was calculated for 7 inhabitants, each using 280 liters per day, resulting in a total daily consumption of 1.96 cubic meters per day. And the tank dimensions were designed to store this volume with an initial height of 1 meter and final height of 1.3, keeping the length and width constant at 1.96 meters. This provides a total storage capacity of 2.55 cubic meters, ensuring sufficient water reserve for daily domestic use and minor fluctuations in demand. Thank you.
Good morning, my name is Jorge Cires and I'm going to explain how to use the certain data to determine water losses in a pumping system. We gonna learn about the suction line and the discharge line of the pump. and impulsion. Well, we start with suction, where we have the average flow, the diameter of the pipe, velocity, losses of the material, the coefficient of the pipe, the horizontal length and vertical length. This is for the line of the tank to the pump, and we only have the valve, and only three types of material that you see, and we calculate the equivalent length of the accessories with multiple coefficients, and we get the dynamic height of the suction, that is 4 because it's the minimum possible for in the height, only for suction. Well, now impulsion. Well, in this time of calculate, impulsion have this the same thing, but we have to calculate for every accessories, and we're gonna have different diameters of the pipe or accessories. So we have to check every single accessories from the critical device to node one, and we continue the line to the pump to see the critical line. Well, when we have all this information, we calculate with the different coefficients, and we have the dynamical height of impulsion with the losses and the other things that we calculate, and we have 7.3 meters, but we can change to 7.5. And with that, we calculate the pump with the dynamic height, dynamic suction, and impulsion. We have two type of that, and we add the differential pressure and the head pressure that we can calculate with that 4, and we can have the 32, and we increase with the factor security to 36.8. We use the formula for calculate the potential, the necessary potential, and we have 0.43. But we can use the minimum commercial pump, that is 0.5. Thank you.
Hi, I am Carlos Sarmiento, and according to the estimating in this project, we have some materials that we are going to need in our project. For example, the PVC pipe, that in quantity we will need 55 meters for our house of 2 floors. And well, some other materials, according to the studies that we did, we're going to need, in totals of materials, we're going to need 577.50 cents. And according to the labor, we have the plumbers and the helpers, in a total of $1,496, and an equipment that is going to be the pump. And in total, we have the total estimated that it's going to be around $2,720. Thank you.